As I've said in a previous video, one thing that I always find my students have a tough time understanding is when sets are elements of other sets. And we have nested sets. And so I like problems like this one, like example 2.13, in particular because they test and they show exactly what these statements are saying is an element of or subset of. You really have to think about it. It's not so easy to tell when one set is a subset of another one, or if an object is an element of another set. You have to practice this a little bit and really think about it. So here we have these 5 sets. So I'm going to describe these sets in words. Pay attention to how I describe them, because this is how one should think about a set like this. So here, A is the set containing the set. Let me use different colors. Containing the set containing the 2 elements 1 and the set containing 1. So again, A is the set. Inside of that set is another set, which contains the element 1 and the set containing 1. So in particular, cardinality of A, what's the cardinality of A? It's just 1. A contains one object, namely the set containing 1 and the set containing 1. Right, I know it's confusing, but hopefully, think about it for a second if that didn't make sense, and convince yourself that that makes sense, that the cardinality of A really only contains one object. That object happens to contain other objects, which might be sets, but we don't worry about that. It still just contains one object. You can think of this like bags containing other bags. I know an episode of SpongeBob SquarePants, they're selling chocolate, and they have these little bags that contain chocolate, and there's some salesman selling them bag after bag after bag, and they keep stuffing bags inside of other bags. I always think of this when I'm going through this section. I don't know if anyone's seen that episode. That's sort of what I think of. I just want to go through each one of these sets. So set B is a nice, like, sort of ordinary looking set, right? B is just the set containing the elements 1, 2, and 3. In particular, cardinality of B is equal to 3. It contains just numbers as elements. Every element of B is a number. C is the set containing 2 elements. In particular, C, cardinality of C is 2. Contains 2 elements. One of the elements is the number 1. The other element is the set containing the empty set. Okay? Right, so this is like a bag that's holding the number 1 is in it, and then there's another bag inside of that bag that has nothing in it. Or, I should say that again. So outside bag, there's 1, the number 1 is in the bag. There's another bag inside of it, and what's in that bag? In that bag, there is an empty bag. That's what I meant to say. Yeah, bag containing 1 and a bag containing an empty bag. That's one way to think about this. D is a little bit similar to B, but it doesn't just contain numbers. It contains the numbers 1 and 2. It also contains the set containing the number 2. So, right, think of it like a bag. We have the number 1 in there, the number 2's in there. Also, I have another bag in there that contains the number 2 as well. In particular, cardinality of D is 3. And then E, all right, so I have a bag. In my bag is an empty bag, the empty set, a bag containing the number 0, and just the number 0. So in particular, the cardinality of E is 3. Now, our goal wasn't really to talk about these cardinalities. That's just how I wanted to introduce these sets and talk a little bit about their cardinality to make more sense of them. Now we're going to introduce object. We're going to ask questions like, is an object an element of the set or not, or is one set a subset of the set or not? So we have these 5 statements, and we'll go through each of these and explain why it's either true or false. We're asked to determine if it's true or false. So is 1 an element of A? That's the first question. So I want to go back to my description of A. Remember, A just had one element in it. What was that element? It was the set containing 1 and the set containing 1. That was the element. So in particular, A does not have the element 1 in it. 1 is not an element of A. So this is false. Now it's true, thinking about this like the bag example, maybe the bag example isn't a great example, right? I have a bag containing another bag that has the element 1 in it and another bag containing the element 1 in it. This isn't asking is 1 inside of the bag somewhere. This is asking is 1 a principal object of the set? Is it one of the next layer down? That's what this is saying, right? This set is the only object inside of A. It may contain other things, but we're not worrying about that when we ask this question, is it an element? In part B, we ask, is the empty set, or is the set containing the empty set a subset of B? So again, I mentioned this in the subset video. Whenever we're trying to determine if, let's say, A is a subset of B or not for two sets A and B, we look at, we can think of this like a little algorithm. Look at every element of A and ask, is it an element of B? So we do that for each element of A, and if the answer is yes to all of these questions as we go through each element of A, then yes, it's a subset. If the answer is no to any one of the any one of those questions, then it's not a subset. So, okay. So here we have the set containing the empty set. We're asking, is that a subset or subset of B or not? So every element of this set, there's only one element in it, namely the empty set. We ask if that's an element of B or not. So let's check. Is the empty set an element of B? Well, I look at B. It does not contain the empty set as an object. So this is false. Now, what is true is that the empty set is a subset of B. Here I ask myself, is every element of this set also an element of this one? But there are no elements of the empty set. There are 0 elements to check. In particular, I didn't answer no to any of these questions. And so, yes, it is a subset of B. This is true, but this is a totally different question, right? This is asking, is the empty set an element of B? Right. I know this can get a little bit confusing, but bear with me. So now we're asking a similar question to part B here. We're asking, is the set containing the empty set a subset of C or not? So again, this set only has one element, namely the empty set. So I need to check, is the empty set an element of C? So I go to C. Is the empty set an element of C? Well, what does C contain? C contains the number 1 and the set containing the empty set. In particular, it does not contain the empty set itself. It contains the set containing the empty set. So this is false. What is true here is that the set containing the empty set is an element of C. That's true, because if I go up to C, I see that, yeah, C does contain the set containing the empty set. So while this is true, it's not a subset of C. Set containing the empty set is not a subset of C. Going down to part D here, I'm asking, is the set containing 2 a subset of D? Well, I'll look at the set containing 2. It has one element, so I need to check if this element is a subset of D or not. So I'll look at D and ask myself, is 2 an element of it? D contains these 3 elements, 1, 2, and the set containing 2. Well, yeah, it does. It does. 2 is contained in D. It's right here. This is 2. 2 is in D. And so, yeah, the set containing 2 is a subset of D. True. It's also true that the set containing 2 is an element of D. It's both a subset of D and it's an element of D. Why is it an element of D? Because there, as one of my 3 elements of D, is the set containing 2, and so it's certainly an element of D as well. So that's kind of weird. A set can be both a subset of D and also an element of D at the same time, but for 2 different reasons. Lastly, Part E here, we're asking, is the set containing the empty set an element of E? So I'm just going to ask myself, I'm going to look at E, and I'm going to see, is the set containing the empty set an element of that or not? So let's go up to E. E contains, make sure I wrote this down right. Yep. E contains the empty set, the set containing 0, and the number 0 itself. What was I asking myself again? Is the set containing the empty set an element of E? No. I don't see the set containing the empty set as an element of E here. So this one is false. What is true here, notice that the empty set is an element of D. So what is true here is that the set containing the empty set is a subset of E. Right? So I asked the question, is every element of this set also an element of this set? This has one element, so I need to check, is the empty set an element of E or not? And yes, it is. It appears right here as an element of E, and so yes, this subset inclusion is true. So, right, think carefully about these. We'll see some more problems like this. Think carefully about them. I love throwing these on exams because, again, they're really testing whether you understand what a subset, what it means for a set to be a subset of another set, what it means for an object to be an element of another set. And you really got to think hard about it. So I like these a lot. I hope you find them kind of fun too. They're not meant to trick you. They're meant for you to think harder about these things that we're learning. Okay, that's it.